We've been doing a bit of soul searching, thinking about what really made Nextflow special and how that connected, how we can apply that in other ways. And what we've really settled on, what we've sort of been thinking about is really kind of three core concepts. The first of it is around open science, around the idea that people can come together, work on a single repository, work on a single tool, have domain experts that can all come together and really kind of catalyze innovation via that. I think it's where we see the growth of NF Core and Nextflow. It's really kind of testament to that. And it's something that we really want to like lean into as a company, and something that we see as something that's really important as part of our values going forward. We also think about the kind of concept of scale. I remember the first time I ran a Nextflow pipeline, I was at CRG, and you just sit there and you type in, you say Nextflow run, and just hit the cluster, and then you get an email from the sysadmin, and like you've just absolutely blown everything. But it has this ability to really run things at scale, and we were doing that previously in HPC, and this is kind of something we continue to do. But when we apply that to the cloud as well, it's just incredible what we can kind of see there. The challenge that we all have today as scientists is actually how we analyze so much of that data. How can we do that and make it accessible to so many people as well? So something that we're really thinking about is how we can continue to push that scale across really many different sorts of applications. And finally, I think that the thing that we maybe speak most about from a technology perspective is flexibility. And this concept that we can take modern software engineering tools and really apply them to science. Really take those tools and make them applicable to the kind of work that we do. And I really think that that's a lot of the essence of what we've done. So this process, I guess, we've gone over the last year is trying to understand what that essence is, distill it down, and then kind of use that to apply to a lot of the other work that we do. Going a little bit more practical here, of course, like the idea of connecting into any compute, the fact that independent of where you're running, if you're running your pipeline in AWS, in USS1, or you're running your pipeline in Germany on an HPC, or you're just developing locally, that you can do all of those things and you can really have that same developer experience. Concept of connecting your data, your storage, and this is something which is becoming increasingly common, that the data is spread in many different locations. The cost to move the data is obviously extremely expensive. The fact that you can spin up resources where the data is becomes incredibly valuable, but also you just want to connect into it, provide visibility on it, and connect into where those resources are. For us, containers are really a core concept. It's something we really pioneered back in 2014, saw how they were being applied in terms of long-running web services and how we could apply them to data pipelines. And in doing so, it was a sort of a challenge that everyone had in terms of running these pipelines reproducibly, portably. But in saying so, we can also take that and now apply it to many different technologies. And this is something we'll speak about, and which Paolo will speak about later on. And finally, the concept of source code management, that there is a single repository that anyone here can have permissionless access to download, to view, to contribute to. And it's that kind of collaboration which allows domain experts to kind of come in and do that. And these are kind of modern software tech concepts, but we can apply them to science. And when we apply them to science, we really end up with scientists kind of working in this way, empowering them, and then for them to be able to also apply that technology to broader groups as well. We've settled on this idea of the modern biotech stack. Now, it kind of sounds in some way that it's very precise, it's very prescriptive and things. But when we think about it, we think about the concept of modern and modern software engineering, the idea of applying modern technology, and a more broader concept of biotech, not just the simple application and thinking about biotech in terms of drug development, but really about how we can combine technology and biology together, and then using that for more general advancements of health, of food, of environment as well. And I think one thing that we've leaned into a lot is the concept of a stack, that the tools that we all work with are multitude. They're various. There's many different things. There's no one size fits all. And in doing so, being able to really provide folks and to give people that full stack helps a lot in terms of being able to give them the flexibility, mix and match, and something that was kind of more of a modern software engineering approach. Summarizing that and thinking about what we do with Nextflow, so obviously Nextflow has been around a while, but it's really providing an anchor here. The anchor is providing those scalable scientific pipelines, and also kind of building on the idea of using containers, running things in a distributed way, which is not always easy to do, and making it possible for folks to connect those pieces together. When we look at other things and related way, multi-QC has a kind of open science component where people build plugins, they build essentially extensions for particular bioinformatics tools, and then they can then be used, reused, and applied to those pieces. Slightly lower in the stack, we can think about container provisioning, and Wave in particular is incredibly important for thinking about dependencies. When you look at a pipeline, it's often made even from a single process, 10s or 20 dependencies. Managing that, while it's fine that we can define these things for a pipeline, let's say, we often have many, many containers per pipeline. Managing that across different infrastructure is not always obvious. And when we think about the cloud and the storage of the cloud and efficient sort of computational storage, Fusion plays a big kind of piece in this. So last year, we introduced many of these tools. We introduced this stack and how it can apply. And now we're really going to go a little bit deeper and see how we can use those tools and how they can kind of come together as part of what we're doing with Seqera. So many of you know we previously had Nextflow Tower. So Nextflow Tower has been renamed into Seqera Platform. It's really a single platform that combines many of these things in a way which makes it easy. It's a kind of a way that you can deploy this full stack application. You can go all the way from data generation through to insights, and also having many different ways which you can interact with it. I think from a very simple perspective, you can think of Nextflow as a single user command line tool. It doesn't have a database. It doesn't have an API. It doesn't have a UI that you can interact with. Really by building those things around that, which is what we sort of started with, we realized that we can sort of leverage that approach and apply it to many different sort of other applications which are very adjacent. Pipelines are a difficult problem, but they're not the only problem. And that's something that we're sort of been thinking about more recently as well. Built, though, on the tools that you use. So building on the infrastructure that you have, whether that's in HPC and cloud, whether that's you use GitHub or GitLab, whether that's that you're connecting in with container registry X or container registry Y. For the way that we build it, it's really a way to integrate all of those tools for you to be able to use them and kind of bring all of that together. Of course, there's a key component of this, which is the open science foundation, the idea that you're building content, you're creating pipelines. You can take something from NF Core. You can develop a module in multi-QC. You can build a container from biocontainers and bring all of that together into the way that you need to do it and kind of continue to leverage, in some sense, the kind of community resources there. Finally, what we're trying to do, some of us are really kind of in the production setting where we're running the same thing often and often. Many of us are also developing pipelines which we want to give to other folks. We want to make those pipelines available. We want to make those analysis available. And the key thing is kind of giving people an option on how they do that. A lot of that comes from the kind of interfaces that we do. So Nextflow command line tool, we've been building UIs, APIs, and trying to make things a lot more accessible for a whole bunch of folks. Now, I think it was great we saw the talk before, what they've been doing with the Australian Biocommons there. A great example where even within one organization, it's got a deployment, it's got installations in clouds, and actually in all the clouds, in HPC, kind of running everywhere, really means you need that flexibility. That flexibility is something which is just sort of essential to run in this way. And it also means that when you deploy the application, you want to be able to deploy it on enterprise, in your HPC, in cloud and then connect into those resources as well. So something we kind of coming from an open source background, it's kind of very important to think about that, but we just see the demand from users and how they want to run the application. It's very important to do that. I want to jump now more into the kind of use cases that we see for pipelines. We've focused a lot on here, on this kind of, I'm sure you can see my cursor, on the kind of concept of like running these really high throughput pipelines, really data analysis pipelines, batch computation. That's really one piece of the puzzle. It's a difficult problem. It's distributed typically. It's something that you need to run very long, but it's really one piece. What if we think about the other parts? How do we write tools and software? How do we run those analyses? How do we interact with the results and then really kind of generate data? And often it's a cycle. It's a cycle that you're going through. Maybe you're more in a situation where you're iterating, maybe you're more in production, but all of these pieces are really valuable. And that's something that we've been thinking about, how we can apply and basically make Nextflow pipelines kind of more accessible in this way, kind of across that whole data analysis lifecycle. I'll just give a quick recap on what's been happening with pipelines. So obviously concept, Nextflow pipelines, scalable, really connect them to your tools and run these things in a collaborative environment. So the concept that you have an application which you can run them in. We look at a quick overview of what's happening there, obviously connecting into cloud, HPC, Kubernetes. We have developed a way where you can have custom user interfaces. So you can create drop-downs, you can draw up UIs, you can create any kind of front end that you want for that. We've also been consolidating these diverse computing resources. So from the example before, independent of where you're running, you've really got that single place that you can find all of that. When we look at what we've been going on the last couple of months, it's really about making those pipelines a lot more usable in terms of the details, really treating pipelines like a first-class citizen, a little bit like Nextflow treats Git repositories, linking them to runs, importing and exporting, really treating them in a way which can be seen. The costs and the budget control is also a really big one, something we've been focusing on a lot, how you can track costs, but also associate particular costs to a particular run. And as groups expand, a lot of the hesitancy in using cloud comes from folks who don't feel that they can have control of those kind of cloud budgets. And making that possible is a kind of big goal of what we're working on, particularly when you see the kind of academic use of that. Optimization is massive. We have customers and users who spend $10,000 per execution. So the amount of compute which is going on here is massive. If anything that we can do to improve that, whether that's through making the storage more optimized with Fusion, running things on Fargate, so you get faster startup times, you get quicker results, and also kind of multi-architecture loads, things like AWS Graviton and things that are coming along. The other thing is really about making the whole environment replicable. We think about an Nextflow pipeline, you can just say Nextflow run, drop your repo. Really applying that same concept, but not just to the workflow execution, but really the whole thing. So can you say, I've got this workspace and it's got 10 pipelines, and each one of those pipelines is represented by a JSON file which I can import and export. And Harshal's going to give a great talk on this later on, where we basically say how we can replicate the whole research environment, make everything sort of work in that way. So I'm going to jump into a demo now. I give you a slight warning that this is going to be a slightly edgy demo in the sense that I have many new parts going on, but we'll jump in anyway and go from there. So I'll start off with giving you an overview of what we can do with pipelines. So here you can see we're logging into the Seqera Platform. Once I log into here, you can see I can log in. I have a view of different pipelines that are available here. We're going to run through an experiment today. We're going to do an experiment where we're going to search in CBI. We're going to find some samples that we want based on the accession. And then we're going to upload them as a sample sheet and really download from there. So in the first case here, I'm going to go to NCBI. And I'm going to search here for this particular search query where I'm looking for these RNA samples that are not a cell line and really find what's available in public resources here. And when I do so, you can see that I get a search, I get a series of samples which I can select. And obviously, I can query these, I can kind of go deeper into these. But by selecting them in the first case, all I'm going to do is download the accession numbers. I just really want those SRA accessions, which we're going to use as the input to a pipeline. So I'm just going to save those as a file here. And then in doing so, I'm going to get a file here. And that file itself, we can kind of interrogate it a little bit more. But in particular, I've just created what we call like a sample sheet inside of here. And inside of that sample sheet, we're just going to have some columns, really like CSV file, very simple, with some description. So just a quick kind of recap on what we can do here. We have a concept of a launch pad where we can launch pipelines. We have a concept of runs where we have history of those workflows that have been run. We have a data sets I showed you before, computer environments. I think the real value here is that I'm in one workspace, but I can run that compute really wherever I have a computer environment, whether that is running in my AWS Ireland environment, or running this in Azure in Virginia, or whether I'm running this in Helsinki, in Google. All of this can be really built into here, and it allows me to have the same pipelines, the same code, and really just change out those computer environments independently. This is particularly important. These examples may look a bit extreme, but imagine you have a development environment, a test environment. Imagine you have multiple AWS accounts which you work on. Imagine you're in different regions. The ability to standardize much of this infrastructure is really important. So we have our data set, which we've uploaded from before. We can see that when we go to run the pipeline here, we can go create a launch. I'm going to choose the fetch NGS pipeline. This is an NF core pipeline. And this pipeline takes accession numbers, so I can literally just feed in what we downloaded here. I'll just give you a quick look of what that looks like. You can see we're pulling from NF core. We're running a specific version. We're running 1.10.1. We've got some labels on that, and I'm going to launch that pipeline here. I mentioned before about this customized UI, which is available. So this is something which has been developed and is part of the Nextflow schema. You can apply a name. You can find the input. So in our case, we're going to look for the input that we have. But I think the really cool thing here is that we can define what we want the output to be as well. So we can say, hey, I want to run after this RNA-seq, or I want to run after this ATAC-seq. So in this case, I'm going to find I want to run RNA-seq pipeline, choose the RNA-seq here, and then it's going to show for me all of the data sets that we have uploaded, and we can launch the pipeline from there. In this case, it's going to take the individual samples, it's going to get all the sample sheets, it's going to pull the FASTQ files, and we're going to be able to launch and run from there. I'm going to, instead of sitting here for 20 minutes and watching this happen, I'm going to show you one which we completed earlier. It's a little bit like cooking show. So I'm going to jump into here, the fetch NGS, and this was one which we ran earlier. And here you can see that the command which has been launched, we can see that we have parameters, configuration, and any data sets that we launched. So we're linking back to the original data, as well as the execution log. But most importantly, I want to show you the reports. This is the output of that pipeline. And remember, this is just downloading files from wherever, in this case SRA, and giving me a full sample sheet with all of the metadata. So now I have the sample. I have the names of those FASTQ files, the strandedness, I have the accessions, whatever was in that with that information here. So I know I have all of that bound to the sample sheet. And the concept of sample sheets is pretty simple. It's CSV, TSV files, but if we use them in the correct way, we can actually get relatively relatively far. A little kind of quick touch on some of the things I showed last year and how they've improved. Well, if we think about the optimization of pipelines here, here is an RNA-seq pipeline, which we've run before on human samples. We now have the optimization. So I can define a machine learning model based on an execution. In this case, I'm looking at the RNA-seq pipeline, which Dr. Patel ran a couple of days ago. And I can see I want to determine what the CPU is going to be, what the memory is going to be, and then from that run can determine a configuration profile. Lots of different tasks. Obviously, doing this manually is obviously a significant step, but it obviously helps. It helps a lot there. Okay, one demo down. That was actually pretty good. Okay. kind of onto roadmap and how we think about that. Well, obviously tracking changes within the pipeline details is really important. We want to bring the same versioning that exists within Nextflow pipelines. We want to reduce the wasted time on validation. Like in this way, when you launch a pipeline, it still needs to run, and then only when it runs do you get this validation step, do you understand what's happening if the data exists, etc. So really removing those steps to make things much more efficient and kind of giving those results to users earlier. We also want to be able to make the pipeline much more interchangeable. So at the moment, how can you take a pipeline and say, I want to give it to person XYZ independent of where they are, using Git as well and kind of making the pipeline more of a Git object, and then really the tighter integration with data. And that's kind of what I'm going to go into next. We have kind of in some way just given the data as being like, it's a, this is something we leave to the reader to make up in some sense, and it's something that's always bugged me a little bit, and I'm very, very glad today to be able to announce that we've really made huge steps and huge strides in solving that problem. So today we're announcing the public preview of a feature that we're calling Data Explorer. Data Explorer has the same concept of Nextflow in that it connects in with your buckets. It connects in with the storage that you already have, but it provides this ability to visualize, to search, and to manage that data. So this is available in a public preview today. So if you go onto Tower Cloud, you'll find that. Giving you a quick overview of what it does, well, it really looks across those clouds. So I mentioned before, if you've got different accounts, different cloud providers, different regions, it provides you that view of that. It has this ability to link the pipelines and the data together. Super important for troubleshooting, if you want to dive into a work directory, for example. We also have the ability to browse and to download and to upload. The object storage and requiring that every scientist has access to your AWS console, no offense to AWS consoles, but it's probably not what we want to be doing in the kind of long term. And so providing this interface that enables the scientists to do that really reduces a lot of time as well as costs. And finally, that area of like linking in public data sets. We strongly believe that many of the public data sets are moving to cloud. I actually remember very early conversations I had with Paolo in 2015. He said, one day it's just going to be there. And like, it's true. The data is just going to be in the cloud in some sense, and it already is in many ways. So providing this concept that we linked into that data, and I kind of show you how that works as well. When you think about it, it's linking in with the S3 blob storage, Google Cloud, so very much similar to what we do already. It adds buckets automatically, so whatever credentials that you have in your workspace, it's going to use those credentials, and really the access to those credentials, really the access to those buckets is driven from those credentials. So system admins of cloud have full control over what's going on there. As I said, we're very excited to launch this today in Seqera Cloud. So we'll jump into demo number 2 and see how we can go with here. So jumping into Data Explorer, that last example which I just ran previously, if we want to imagine what we did there, we just had our run, and if we go into that particular run that we had, there was a report which was generated. That report, the result, was really a kind of a data set. It was a CSV file. But what about the underlying files? What about like, where is this file actually? This is just a metadata or associated data, I should say, on top of that file. How can we go into that? So you can see here, this is in the Seqera Lab showcase bucket. If I was to close this here, I can now jump into the Data Explorer. Inside the Data Explorer, I can see all of my buckets that are associated with my credentials. So you can see I've got some AWS bucket here in EUS1. I've got some test data in EUS2. You can see I've got some Google storage buckets, etc. Really, everything is accessible from a single interface. If we go down into the Seqera Lab showcase, I can find that exact run I had previously, which was the NF Core NGS run. Inside of that, I can find particular results. I can jump in there and find the sample sheet, exactly like I just showed you a minute ago. But I can also go and show you the original files as well. So in this case, I could download this, but I can jump in and find, for example, the actual FastQ files. So it provides a really kind of easy way to navigate, to integrate with your actual results, where they are, and kind of have that much more kind of native experience with that. That's like one direction. What about the other direction where you're like thinking about what files did my pipeline create? If I have a particular run, how can I access and view those files? So if we go to that same run now, we jump in, I can go and find the work directory, so I can basically link into like what happened. Super useful for debugging. If you're familiar with Nextflow pipelines, they create these work directories. Being able to jump in there and see exactly what's happened from the workflow level is important. You can even go deeper and you can say, show me at the task level. So I can jump in to the task table. So this pipeline, just recap, 34 tasks, 34 containerized executions. Each one of those executions has got its own log, it's got its own data explorer. I can jump in and find those files and see them there. So it just helps a lot with sort of many aspects of managing those pipelines as well. How is this kind of driven? Well, I mentioned before it's kind of coming from, a lot of this is really coming from the credentials. If I look at those credentials, I can see I've got Azure credentials, AWS credentials. I can kind of, whatever credentials I put in there is going to automatically load in. But I can also kind of go beyond that, and I can start to add public resources. And I think this is where things start to get really interesting if we think about the cloud as the kind of default location for many of these things. Jumping in and jumping back into the Data Explorer here, I'm going to now search for example, 1,000 genomes. Slightly old, but it's been kind of a classic. So we can search for that. We can find the 1,000 genomes bucket. And in this case, it's really just an S3 bucket. So that means I can copy the name of it. I can take that bucket there, and in this case, I'm just going to jump back into the Explorer. I'm going to add the bucket as a AWS public bucket, and then I'm going to give it a name or whatever, give it a public thing. Press Add. Cross fingers. And then if you can see that now, just with that one thing, I have access to all 1,000 genomes data. I can simply take that in, bring it in, and load it anywhere I want. It kind of goes further than that as well. I can do the same thing with reference data. Here's some data from our friends at the Broad. They can see that here we can access all of reference data. I think the thing I'd like to stress here is, though, that this is moving the workload to the data. So that data still exists there, but I can now run my pipeline, or I can run my analysis where that data is. And that's the really key thing, because no one wants to move that stuff around. That's very expensive. But if I can spin up a computer environment in that location, like I've done here, or like I could do here, then I can simply access that data and kind of run it in that location. There's a couple of other things we have. We've got upload and download, really kind of the ability to kind of take that data as well, link it with other things, but it's really kind of a first step for us, and just linking, really making that connective tissue between pipelines and data, and something we've been looking to do for a while as well. Okay. Where are we going for the roadmap for this? Well, the first thing is kind of obvious, like linking the input and the output with that. So basically making it easy when you select the pipeline you want to run, which data do you want? The validation of that's going to be really important as well. How we can search for more public data sources. I was showing you buckets, but there's no reason we can't do the same thing for SRA, for things like benchling, for base space. We also want to support shared file systems, things like NFS, HPC systems, and really kind of data packaging and provenance, and kind of looking at some of the kind of ecosystem products around that, and what can we leverage that exists, that users are already using, and kind of applying that to this as well. And this kind of takes us on to the next step, which is, this is kind of we thought about like the data management piece, but if we think about how we can make those sort of analyses, that data accessible to many people, for everyone that runs a pipeline, it's really my view that there's 10 people who want to run a notebook. There's 10 people who just want to touch that data, who just want to interact with it, who want to write a small script, who don't want to spin up something really big. And when we think about that, that's something like whether that's the end of a pipeline, whether that's really development of the tool that you want to do. This is really what we've been thinking about in terms of what we call a data studio. So just a kind of quick recap. Data Explorer is now available today, so if you log into Tower Cloud, you'll find it available there. You can log in and access it there. It's going to be released in version 23.3 in about a month or so's time. Going beyond, say, that batch piece onto the interactive and how we can think about that, also very excited to announce something that has also been a long time so in the wings as well, which is around a product we're calling Data Studios. And Data Studios is available now as a private preview. It links the ability to create notebooks, interactive applications, where your data is in the same environments that you run Nextflow. The concept here is that we can really take RStudio, Jupyter Labs, VS Code, really anything that you're currently familiar with using, taking that downstream analysis from the pipelines or debugging pipelines or really developing new things and connecting them in where you run that things as well. I think the really nice thing about this is that when you're developing a pipeline often, you kind of need the real data. You need the real environment. It's all fine and it's great that we develop locally and we can try and make things as standardized as possible. But in reality, sometimes it's just being there in that environment with that data makes all the difference. And particularly when we think about mounting sort of cloud data and data around, it's something that can help a lot. When we think about what Data Studios and how it works, we leaned in a lot to the container here. We have 10 years experience of running Nextflow containers and running Nextflow as a container as well, like it runs in platform. How we can think about the dependencies. It's really, I don't know if you spend much time in RStudio, but like defining the dependencies of bioconductor, for example. Extremely painful thing, particularly if you want to make that replicable. How can we learn the lessons of Nextflow, reduce the challenges that exist in terms of defining dependencies and things like Jupyter and RStudio, and kind of take that technology and give it to a whole new set of users. We want to make them portable and shareable and collaborative. Really just like the same way that a Nextflow pipeline, you drop a repository. How can we do the same thing with interactive environments and really have that kind of access control through Git credentials? Okay, this is the most risky one. So we're thinking about how that looks like. So we now have Data Studios, which is available, say, as a private preview. You can add a studio exactly like you would almost create a pipeline. So I can choose the studio that I have. The future is, of course, to choose really any image, whatever image you think is relevant. In this case, I'm going to choose an RStudio environment. I choose a computer environment that I wish to run. And I think this is the real key. This is what makes this a little bit magic, is the concept that I can mount whatever I want. So I can take, for example, my 1,000 genomes bucket that I had, or I can mount inside of here reference genomes that I need, or really any data that exists, the output of my pipeline, for example. And when I do that, I mount that data inside of here, and that data studio which gets created, I can use that data in a way. I will show you some kind of what this looks like in a couple of examples. And I think these hopefully are kind of illustrative of what we can do with here. So first in RStudio, you can see here that I have really like an R Markdown file. This R Markdown file is actually taking the output of NF-core RNA-seq. So NF-core RNA-seq creates a file, which is an expression file. And what I can do is I can read that file in. But importantly, notice here on the right-hand side, you can see it okay, but here's the data. This is really mounting the bucket that I had inside of there. And I can mount the bucket inside of the container, so inside of that environment, and then run it in that way. So here I've got an expression matrix, which I can generate. I can run my RStudio code in here, create that expression matrix, and then generate my graph. I'm going to go to another slightly, I guess, slightly more new age example with Jupyter. Likewise, the same thing. I've mounted the data inside of here. now I'm going to create a pandas data frame from the same data. So it's a TSV file with genes, as well as samples, and then the expression of those genes in that file. Just going to launch that. I'm creating a data frame. I'm going to load now the Jupyter AI module. What this does is it allows me to feed data into my data, the data I've loaded from Fusion, into here, and I'm going to pass that to OpenAI. And in this case, I'm going to ask it to write a script for me, and that script is going to say, take the output of this tool, which is a salmon tool from gene expression, from NF Core RNA-seq, write a script for me that's going to generate different figures that are commonly used for differential expression analysis. So when I launch this now, this is going to take that input full, pass it in here, run that against that. The data, the original data here, though, is browsable from here, so I can access that. It's really the output of my pipeline. And from that, it takes a couple of seconds to load through. I'll just give that a moment. And in doing so, it's going to generate for me, hopefully, it's not exactly reproducible. It's going to generate for me a script which I'm going to be able to run and generate some figures from that. Kind of an example of how we can really combine things together and perhaps to use this concept of particularly in AI. Yeah, here we go. Just want to point out here, it's very specific. So it's really determined the different conditions which are available here, kind of gone in and be able to generate that as well. If I was to take an example of that and run that, you can see we get gene plot expressions, we get different parts, we get an expression plot based on that, and we can get different things. So lots of kind of interesting things. I'm going to finish off with like the last part of Studios, and this is really about not interactive analysis per se, but really about development. If we think about how we can develop those pipelines in that environment, we also have available VS Code. Now, I know there's like many extensions for this, so what we can do here is we can pull in our pipelines, develop those pipelines in situ, in the environment where we have access to that information, and really close off. I'm not sure if it's a complete term, but there's interactive development environments. I really think we're creating interactive scientific environments here, things that people can build on, people can use, and kind of go from there. Okay, kind of if we think about sort of roadmap from here, as I mentioned before, dependencies. This is a very difficult problem, something we really want to work on. Replicating those environments with snapshots, supporting different clouds as always, supporting HPC, supporting Kubernetes. It's really, well, as working with the community. Nextflow became a de facto standard, but it wasn't intentional. It was something that came out. How can we do the same with these kind of environments? What do people want to define their dependencies as? There is a couple of standards which exist, things like dev containers out there. Are we going to build on top of that and kind of use that to be able to build interactive scientific environments? Finally, this is available today, so in terms of a private preview. If you go to this website, put in the details, we'll sort of contact you to make it when it's available. We'd love some feedback on this as well. It's really kind of new stuff we've been building on. Ideally, kind of completing this, it's still very early days of what we want to do. And as we kind of think about completing this whole data analysis lifecycle, something that we see that there's a whole lot of potential to close off and just really make much of this stuff much more available to folks. Just kind of point out on how this is available. We have Seqera Cloud Essentials. This is a completely free product which you can do. You can sign up for Seqera Cloud. It includes pipelines, Data Explorer, and Studios across all of the clouds. Limitations are around just the number of people that you can have in your organization, as well as workspaces and concurrent runs. We also have a new academic program, which we are launching, which is Seqera Cloud Academic. So this really gives you all of the fully functioned Seqera Cloud Professional for academic institutions. So you can apply to this and you can tell us what your organization is, and we will kind of give you fully loaded on that. Just a reminder, there's cloud, there's enterprise. You can deploy this where you want. Independently, though, the computer environments are kind of running there. So it does give you a whole bunch of sort of options on that. And then just finishing up, what I would love to see in like something it's an evolution, but it's something which has come to me more relatively recently, is kind of thinking about the infrastructure that we build, but not just the infrastructure, the resources. When I look at NF Core, the value is really that content. It's really the people building incredible stuff. And how can we replicate that in other places? How can we do the same thing for software, like biocontainers? How can we do the same things for data? How can we do the same things for interactive environments and studios? So I'm really looking forward to being here in a year's time and maybe figure out some of those problems. But in the meantime, I really want to thank so much everyone for the time. Hope you can see we're really excited. Obviously focusing a lot on these things, and come talk to me during the rest of the couple of days. Would love to chat. Thanks so much.
Thanks, Evan. I should like to point out, I saw a quick preview of this on Sunday, and I was thinking to myself, this is really impressive, but I'm a bit scared. So congratulations for pulling that off with those live demos. That's good. As you might expect, lots of questions coming in about this. Hats off especially to Anthony and staff who came in early with some questions asking about whether it might be possible to browse files in Tower and download them, maybe even launch Jupyter Notebooks one day. So yeah, just to beat you to it almost. One of the questions here from Philip, is it possible to integrate an external LIMS API to create a web app where one can choose samples to process in Nextflow Tower?
It's a good one. We've started on kind of building those buckets. Those are essentially API calls. They are the kind of the most obvious thing to do in terms of representing that. We're looking right now, in fact, we have a project underway to do a similar thing with things like benchling and other LIMS, SRA as well. So that's kind of already underway. We're just basically picking off the pieces that we see the most users. And so if you do have particular databases or things that you want to access, let us know, and that's kind of something that we can kind of prioritize as we build it out. There's a slight, I guess, concept of like the kind of data source, and that we have files, which are typically used in bioinformatics, as well as kind of more structured data, which you would think of in databases. And we're still kind of working out exactly how those things live side by side and how you can kind of manage those.
I've got a question from Stav again. Does Data Explorer work for on-prem file systems?
Currently not, but if familiar with how the execution works of pipelines, we have an agent, and that agent essentially is able to retrieve the information and execute the pipeline via connection with the application. So the idea is to do something very similar with this. So it's kind of early days in that, but it's definitely our intention to build that out.
I've got a question here from Adam. He's asking about the Data Explorer. He says, can I use Platform without allowing Data Explorer access to my buckets?
You can, so I guess there's two parts to that. You can hide buckets. That means that they're basically not accessible to people. But then you can also control the access of the buckets given the credentials. So this is something we'd recommend, is that you look at the credentials which you are giving to the application and then really determine what buckets are available and kind of go from there. Very much kind of standard cloud security policies, but obviously kind of making them accessible.
Personal follow-on from that. I mean, is it possible for someone to set up access for other users within Tower to certain buckets without them knowing the credentials?
Yeah, absolutely. So it's all driven from the security boundary of the workspace. It sounds very technical, but it basically means whoever's in your workspace, you define what they can do. You can define what they see.
We'll try and skip a couple, sorry, but a couple of questions about Data Studio before we wrap up. Abhinav asks, which languages would be available within the Data Studio? Can we build the custom environment container as a basis?
That's a great question, yeah. So we've designed it, obviously, to begin with the most ones which we see the most usage of, but in essence, it is general containerized compute. Nextflow is a single container. It's created and it launches multiple containers into the environment. This is really even simpler in some sense. It's a single container execution into that environment, very much like the head job that you run. And the way that we're thinking of building this is that you can run any container compute. So in the case that I'm showing, it's kind of the obvious ones, but there's no reason that if you have your own customized environment that you want to spin up, if you want to have, for example, an R-Shiny application, or you want to have some kind of custom compute that you want to run as a service connected to a database, it's all very, very much part of the plan.
One last one. Can you write an ad hoc Nextflow pipeline in the VS Code instance and then run the pipeline directly without a GitHub repo?
Yes and no, you can do it, but it's not very easy, I would say. So this is one, going back to my diagram before, I'm a little bit cheating here, to be honest. Like, this is the kind of goal where I want to be developing, like, wherever I am and be able to do that really quickly. At the moment, it still goes through a Git repository. The way that we're thinking of fixing that is thinking of things like VS Code extensions, which can connect with API directly. So you can imagine pushing to a Git repo, and then basically using the Seqera Platform API to have an extension which will kind of launch that and remove a lot of the faff around that.
Okay, thanks very much, Simon.
Awesome, thanks so much.